All right, welcome. So today we will continue our explorations into the world of probability. And today's session will be about the foundations of probability, and in particular, the issue of what it means anyway to talk about probabilities. So I want to start with an example. Does anyone know who Glenn Seaborg was? It's a very interesting guy. So he discovered a bunch of new elements, and he was also the first person who managed to isolate plutonium. So he was given the remains of a nuclear reactor, and it was, of course, very hard to separate different isotopes of uranium, but he was able to separate whatever traces of plutonium were in the sample using chemical means. So very cool. And in his honor was named a chemical element, seaborgium. And seaborgium has an isotope seaborgium-265, whose half-life is 8.9 seconds. So that means that if you have such a particle and you wait 8.9 seconds, the probability that it will decay is 0.5. So one question for us today is, what does that mean? What does it mean to say that its objective probability of decay is 0.5? Okay, so that will be our final issue, but actually the situation is complicated, so we're going to take a circuitous route to answering that. So the first thing I want to do is contrast two different ways of thinking about probability. So we have what philosophers sometimes call subjective probability and what philosophers call objective probability. Subjective probability is supposed to measure an agent's degree of belief. So suppose that I asked you, do you believe that this particle of seaborgium-265 will decay within the next 8.9 seconds? So presumably it would be wrong for you to say, yes, I believe that it will. And it would be wrong for you to say, no, I believe that it won't. And presumably you have something like belief to degree 0.5. Maybe one could put it by saying that you are certain to degree 0.5 that the particle will decay. So what that means is that your subjective probability is 0.5. So subjective probability is an agent agent's degree of certainty. But objective probability is supposed to be something that has nothing to do, at least not immediately, with the beliefs of particular people. So even if there were nobody in the world to have beliefs, the idea is that the probability that my particle will decay within the next 8.9 seconds, they would think that that probability is still objectively 0.5. So the first observation for today is to notice that we have this notion of probability, which is supposed to be something out there in the world. It's nothing to do with how we think about the world. It's supposed to be a property of these particles. Now, people do think that there's a certain kind of connection between subjective probability and objective probability. Does anyone have a hypothesis about what a good connection between the two might be? So if you wanted to state an axiom relating the two principles, the two notions, what would it be? Yes?
Well, maybe if you had perfect knowledge of the world, then this subjective probability would be the same as the objective probability.
Yes. So if you had perfect knowledge, and let me add, if your belief-forming mechanisms were perfectly rational. Because if we have someone who has full information but is a fool, then they're not gonna reach the right conclusion. So I'm gonna write a version of that down. So one might think that the following axiom holds. Okay, so there's our axiom. The objective probabilities are the subjective probabilities of a perfectly rational agent with perfect information about the world. Okay, I mean, that's not quite an answer to the question of what objective probabilities are. It's more like a recipe for being able to recognize them. But it's something to work with.